All right, let's talk about calculus. For a lot of us, just hearing the word derivative is enough to make our brains kind of shut down. It feels like the point where math gets super abstract and just, well, complicated. But here's the secret. The main idea behind it all, it's actually something you already understand.
So, does this formula look like some kind of alien language? Yeah. If you're nodding right now, you are definitely not alone. This formula right here is usually where most people get completely lost. And you know what? It's for a very good reason.
And here's the thing. The traditional way we're all taught calculus has us memorizing formulas just like that one before we have any clue what they actually mean. It's like being asked to memorize a bunch of grammar rules for a language you've never even heard spoken. It makes no sense. So today, we're flipping that completely upside down. We're going to start with the concept, not the crazy formula.
So, you want to know the real secret to finally understanding what a derivative is? Let's just completely forget about the formulas for a minute. We're going to start in the real world because this is where it all finally starts to click.
Okay, this is crucial, so just let this one sink in for a second. A derivative is just a measurement of how fast something is changing at one specific single instant. That's it. Seriously, that is the entire core idea in one sentence.
To make this crystal clear, let's use an example you deal with all the time. Just imagine you're in a car. You're driving down the road. Pretty simple, right? Your position is constantly changing.
So you glance down at your speedometer. It says 60 kilometers per hour. Now really think about what that number is telling you. It's not your average speed for the whole trip. It's your speed right now, at this precise moment. And that instantaneous speed, that is a perfect real-world example of a derivative.
So let's break it down like this. In the language of calculus, your position on the road, where you are, that's the original function. We'll call it f of x. But your speed, how fast you're going at that exact spot, that's the derivative, or f prime of x. See? It's that simple. One tells you where, the other tells you how fast.
And this brings us to a huge point of confusion for so many people. So listen carefully. If you see f of 2 equals 4, that's just a location. It means at point 2, your value is 4. Simple. But if you see f prime of 2 equals 4, that's a totally different story. That's about movement. It means at that exact point, you are changing, moving forward at a rate of 4. It's the difference between a location and motion.
Okay, so the whole speedometer thing makes sense, right? It's a number. But what does a derivative actually look like on a graph? Let's switch from numbers to pictures, because for a lot of us, this is the moment where that light bulb really, truly turns on.
Here it is, the big visual secret. A derivative is just the slope, the steepness of a line that just barely kisses the curve at one single point. And we call that the tangent line. So when you calculate a derivative and you get a number, all that number is telling you is just how steep that tiny little line is.
And you can literally see this for yourself on any curve out there. It's a simple three-step process. First, just pick a point on the curve, any point at all. Second, imagine drawing a straight line that just touches that one spot and nothing else. And third, just look at how steep that line is. That steepness, yep, that is the derivative.
So here's how you can read any curve. If your curve is going uphill, well, the slope is positive, so the derivative is positive. If the curve is going downhill, the slope is negative. And if the curve is perfectly flat, like right at the peak of a hill or the bottom of a valley, the slope is 0.
So why does this matter so much? Because you've just unlocked one of the most powerful tools in all of calculus. If you ever want to find the highest or lowest point on any curve, the maximum or the minimum, all you have to do is find the exact spot where the slope, the derivative, is equal to 0. That's the whole secret. Okay, so now you get the what and the why. You can actually see what a derivative is. But how do you make this really stick so you don't forget it? Well, here is a super simple action plan to take you from just understanding it to really mastering it.
So check this out. For the first 2 days, I want you to do zero math. Seriously, just notice rates of change around you, how fast a car is going, how quickly something is growing. Then, for the next couple of days, just doodle. Sketch random curves and imagine the slopes at different points. Only after you've done that, then go and look at that scary limit formula. Because if you do this, the formulas stop being these random rules you have to memorize, and they start to feel like what they really are, helpful shortcuts.
Okay, so let's do a super quick recap. A derivative is just an instantaneous rate of change. Think speedometer. Visually, it's nothing more than the slope of the tangent line. If the derivative is positive, the function's going up. If it's negative, the function's going down.
And if the derivative is 0, you've hit a flat spot, like the top of a hill.
So I'm going to leave you with this one final thought. We are so often taught to treat math like it's just a long list of rules that we have to memorize. But what if the real secret to mastering it, especially something like calculus, isn't about memorizing at all, but it's really about learning how to see?